Chapter 6 or Module 6. So this one is all about data communications, and I'm not going to spend too much time lecturing on this one. Just want to cover some of the basics. Now, why do we even cover this? Well, we want to just make sure that as a manager, many of you plan to be managers one day, you understand the basics of data communication. What are some of the major components? How are they set up? What are some common networks? And these things called topologies. We'll look at some of the concepts such as protocols, routing and routers, client server. What does that actually mean? So my job is to try to make this understandable and as clear and comprehensible as possible for y'all. What are some trends? Wi-Fi, WiMAX, Bluetooth, etc., etc., and some of the security issues that are so important. So all data communication is really sending data from one place to another. Human communication, you could be waving, you could be speaking, you could be using sign language, you could be using a telephone. So humans can send data from one place to another. So data communication, we're just talking about electronic transfer. So enabling an information system to deliver or receive information. And there's lots of different ways, so we need to be flexible. We need to be virtual, meaning we're sending things all over the world, and being able to collaborate. So why do you need to know about this? Well, we want to make sure that in your role, you're both effective and efficient. And there's so much more than email and electronic file transfer. But today, just emailing and sending PDFs and attachments, we don't do faxing anymore. So we just want to make sure you're pretty much as up to date as possible. So why would you want to use this in the workplace? Well, there's so many reasons today. Sorry, I had a little pause there. So again, why do you need to know about this? I mean, just look at the way we're using data communication today. Training for almost anything, lifelong learning, searching. And so many of us are learning from home. Well, heck, with Zoom and web conferencing, this is just, the world is changing fast. That's all. Again, I'm going to go fairly quickly on this, which is probably fine with you. And let me go back. Oops. And you can read all this in the chapter, I hope. So some of the things, like, again, what are some of the basics? What is an intranet versus the internet? So the intranet is using internet tools, but just within an organization. An extranet, that would be maybe Walmart would let all their suppliers connect on an extranet and maybe know things about what's going on inside Walmart in terms of who's there to receive deliveries, who's there to pay bills. So these intranets and extranets use internet technology to connect. And then there's wired networks, as you know, and wireless. And some of the big issues today is security. I mean, that's a huge issue. You've all heard about data breaches and people hacking. That's a big issue, and it's global now. So data communications is huge, and we're not going to get to the level of a networking class, but for one chapter it's good to know a little bit about some of these terms, like what is bandwidth. If someone says my bandwidth is whatever, 1 Mbps, 1 megabit per second, that's how much data can be can be transferred. Attenuation, with some different internet providers, if you live far from where the data is sent from, maybe you lose some of this bandwidth as further you go away from the sending device. And then broadband just means you can send a lot of things at one time. It's just sometimes you can stop and think about what's really happening in your home. 3 or 4 or 5 people are all on the internet at the same time, and the speeds are just amazing. Narrowband, that's the opposite of broadband, so it's kind of slow. Protocols, you'll hear about so-and-so protocol. That is simply a rule. We in the United States have to agree among ourselves on how we're sending and receiving data. Now we want to send it to Australia or Taiwan or Singapore, wherever. We all have to agree on some of the same rules. That's just a protocol. So when the ambassador from France comes to the White House, the president should know some of the protocols. How do we deal with we obviously deal differently. Our communication protocol with somebody from Japan, maybe you bow, or France or Italy, maybe you kiss them on the cheek. I don't know, but that's what it's called, a protocol. So how do we detect errors and things like that? Now, sending and receiving devices, again, I wish I could be with you in the classroom and show you so many of these things in person, but it's just we send, we receive. They don't really do anything other than that. Smart terminals can do some of the tasks, like maybe a cash register, but maybe it doesn't do all the things that a computer would do, such as update the inventory back in the computer in the warehouse or something like that. So there's lots of different kinds of sending and receiving devices, but any modern computer today can do this. Most of you have heard the term somewhere in your life called a modem. But what is it actually? What is a modem? It stands for modulate and demodulate, taking data going from like what's called an analog signal, which is like a sound wave, and then making it digital. Digital signals are just on, off. Ons or off, that's it. So converting data from, say, a phone line to something that can go via satellite, then back to a phone line. We modulate and we demodulate the signal. That's where the word modem comes from. Now, if it's 100% all digital, we don't even need modems anymore. DSL, we can send data quickly over phone lines. Cable modems, they usually don't even use. It's just a name to connecting to like coax cable for internet connection. And so a channel, all a channel means is the path. So it could be wire, it could be fiber optics, it could be cables, or it could be wireless, and we'll cover some of those. So there's basically wired and wireless media. Wired would include electrical, like literally in the electrical circuit in your house, you've got copper wires carrying electricity around. You can send data over those via light, like fiber optic cables. So wires and coaxial cables. There's many, many, many different kinds of wires, and there's pros and cons. They're usually very, very fast, very little static, but they do have problems. Like I worked for a Shell oil company in Africa. You put wires and some people literally cut them up, or the salt water can corrode them. Now wireless are subject to interference, but you're all used to radio. That's like your cell phones, microwave dishes, satellites, things like that. And then we have actually light frequency. That's what you have, for example, probably on your remote control for your TV. You have a little red light at the back that literally sends an infrared signal through the air. Or at the cash register. So you'll see the little red lights coming up for the barcode readers. Let's see. Okay, and there's different kinds of configurations. Again, there's lots of, the two main ones we'll look at here are centralized versus decentralized. So centralized means you have one central computer and everybody connects to that. That was like American Airlines. All the data was held in Dallas, Texas. And all over the world, people would make flight reservations and cancel them and book tickets and stuff like that. But the one main computer was in Dallas, Texas. A very centralized system. Well, there's advantages and disadvantages. A decentralized means there can be computers all over the world, and they all do their own thing, but send data back and forth. So there's advantages and disadvantages. After this one, I'll take a short break and move on to part 2. So the advantage of a centralized is very tight control. You only have one place to have all the backups and maybe monitor security and things like that. The disadvantage is it could be a little bit less responsive. Somebody out in some other country in Asia or Africa or Europe wants it to be a little different format. Well, if everything is centralized, it maybe takes a long time to get changes made to meet users' needs around the world. So let me pause there and we'll continue on in part 2 in the next part.